Hello everyone, my name is Takeshi Sakaguchi from Japan, and I am an architect at Takenaka Corporation. I'd like to talk about planning, operation, and improvement of natural ventilation system at Takamatsu University Building 2. The campus is situated within 15 minutes driving distance of downtown Takamatsu City, set in the heart of the Sanuki Plain. The campus extends alongside the rich natural environment of Kasuga River. I've divided my presentation into three parts. First, natural lighting and ventilation strategies for a double-loaded corridor building. Second, natural ventilation strategy and its implementation in double-loaded corridor building with stacked chimneys. Finally, improvement of natural ventilation usage by raising users' awareness. I'd like to start with my first point, natural lighting and ventilation. It has two parts. First, architectural agenda, eliminating the boxed-in sensation of double-loaded corridors. Second, natural lighting strategy with ventilation, flat slab eaves and brise-soleil pillars. Archetypal of the double-loaded corridor building type has the difficulty in sustainably providing ample levels of lighting and ventilation to corridor spaces. In order to admit natural light and ventilation, multiple timber decks were installed. They also serve as informal communication spaces. While many buildings boast large glass windows, overexposure and undesirable heat gains necessitate that the blinds for these be closed, effectively rendering them useless most of the time. In this building, in order to secure ventilation under the natural lighting strategy, eaves and brise-soleil pillars block direct sunlight and admit consistent indirect sunlight into rooms. For instance, I'd like to show you results of lighting simulation in naturally lit south-facing room. As you can see, direct sunlight is suitably abated for most of the day. Let me now move on to second point, natural ventilation strategy and its implementation in the double-loaded corridor buildings with stacked chimneys. As you can see, it has two parts. First, natural ventilation with stacked chimneys. Second, stacked chimneys ventilation promotion effect. I introduce you the natural ventilation system adopted by this building. First, openable windows were installed in both teacher and student rooms on the second and third floors, oriented along a north-south axis. Second, transoms were installed to generate airflow from the rooms to corridor. And third, openings were created at the tops of the stairwells at either end of the building, where the structures were designed to function as chimney stacks in order to secure a route for vertical airflow. In order to verify the chimney stack effect, the ventilation process was calculated based on wind pressure measurements from a wind tunnel test, and the results contrasted against those cases where chimneys were not installed but openings of similar size were created in staircases instead. Analysis results are shown in the upper diagram. Due to air exhaust from stacked chimneys, stable negative pressure is generated, which translates to a stable level of ventilation on the exhaust side, irrespective of exterior wind directions. Also, the lower diagram, which shows the measurement of ventilation amount, indicates a stable generate of exhaust. Now I will show you the third point, improvement of natural ventilation usage by raising users' awareness. First, improvement of natural ventilation usage. Second, improvement of openings. It is important to have users understand the natural ventilation system so that they can make the most of it. Since this building has many intimate spaces, we can expect users to be interested enough in the building's environmental features to engage them. Even after the building's completion, ongoing surveys were conducted, as well as briefings in order to raise users' awareness of and familiarity with the system. Posters depicting a simple sum meter, as shown in left illustration, were displayed in each room in order to raise users' awareness and improve both faculty members and students' understanding of how to utilize the natural ventilation system. Diagram on the right shows the window opening rates before and after the poster were used. The opening rate was higher in fall than in spring, both in student rooms and teachers' rooms, particularly in student rooms where the window opening rate was lower than in teachers' rooms. The rate clearly increased when the outside temperature was in the 18 to 24 degrees centigrade range. It appears that students started to adjust room temperature by closing opening windows. Based on the results, it was revealed that utilization frequency of transom and doors was low. For active use of natural ventilation system, the difficulty of operating these openings must be taken into consideration in design. In this building, 4 types of improvements that are shown in the upper pictures were made. Questionnaires were conducted regarding ease of use for the remodeled doors, transoms, as well as the frequency of window operation. The lower left diagrams show the results of the questionnaires. There was no change in ease of use for D, and frequency of operation decreased. However, the frequency increased for remodeled doors A through C. The lower right diagram shows the comparison for frequency of the openings between rooms and corridors in the 4 remodeled rooms and unchanged rooms. Compared to the unchanged rooms, frequency of use of these openings clearly increased. As such, one might infer that user-friendliness prompted users to actively adjust their environment. In summary, there were 3 key points. First, natural lighting and ventilation strategy in the double-loaded corridor building, which were come true by installing multiple timber decks. Second, natural ventilation strategy and its implementation with stacked chimneys, in which the amount of ventilation was verified both in the window terminal test and the actual measurements. Finally, improvement of natural ventilation usage by raising users' awareness, such as ongoing campaigns and remodels.